In this exercise, we are given a line G and we need to find different lines that are parallel to G, skew to G, or intersect with G. So these are the three cases with a little sketch. And our line, we are always looking for this line H. So here for a parallel H, here for a skew H, and here for an intersecting H. And H always takes the form U plus T times V, with U being our position vector and V being the direction vector of H. And in each three cases, we need to ask ourselves, what are good choices for U and V? So let's first look at the direction vector in these three cases. So what can we say about the direction vector? For two lines to be parallel, we know that their direction vectors need to be collinear. So this means that here any collinear vector could be chosen as our direction vector. And the simplest choice would be just the vector b itself. So here we could choose the direction vector 3, 2, 4, or as I said, any collinear vector to this one. Kind of a different situation for the skew one. Here we need to make sure that they are not collinear, right? So this means, well, pretty easy. We can just change one component, and then this means that they become not collinear. So let's change the third component. We have again 3, 2, and the last component we just put it to 0. And also the intersecting one, also here we need to make sure that their direction vectors are not collinear. So again, 3, 2, 0, or any other vector that is not collinear. So there are really infinite amount of choices here. Okay, so we already have the direction vector for all three cases. Now let's look at the position vector. First for the parallel line. Okay, and we need to ask ourselves what would be a good choice for the position vector. For the position vector, all we need to make sure is that the position vector, in this case u, doesn't point to a point on the line G. Because if it would point to a point on the line G, then the line H would be identical with G. Okay, and we can achieve that by actually choosing randomly any point. Then you're extremely likely to get a point that is not on G, but we could also just change one component here. Again, I choose, well, I will actually change the first one. So this becomes a 0, 3, -1. And now I leave it to you to check that this point here doesn't line on G. Okay, for the skew case, here again, we could choose a point randomly, and we are very likely then to choose a point so that the lines are skew. The point from here would again be a good choice, so 0, 3, -1. And again, I leave it to you to check that this line H doesn't intersect with G. Now for the last one, for the intersecting line H, well, here we have to ask ourselves what would be a good choice of the position vector. And the answer is, well, any point on the line G would be a good starting point. So if we start, for instance, here, and we then have our direction vector that points in this direction, then this will intersect G. Or the simplest choice, we just take this point here. That's the choice that's drawn here in the sketch. So if we choose this point as our starting point, and that's actually given by this position vector here, then we also get an intersecting line. So we can choose the point 2 or the position vector 2, 3, -1. to get an intersecting line. And these two lines, they will directly exactly intersect at this point here, 2, 3, -1.